Good day everyone. For today's video, we're going to talk about the concept of derivative of exponential and logarithmic function. First thing we have to consider is the derivative of exponential function. On this case, we have the base a. So we have two cases po, base a and base e. So first, let's talk about base a. So here's the formula for the derivative of the exponential function to the base a. So we have derivative of a to the u with respect to u equals a to the u times ln of a times derivative of u with respect to x. Take note and bear in mind that we introduce additional variable which is u because of the chain rule. Let's have an example. Find the derivative of this function, 3 to the power of x squared. Now, recognize first who is a, who is u. At this example, a is 3, then u is x squared. Now, let us utilize the given formula. A to the u is simply the original function, which is 3 to the power of x squared. And then ln of a is the next term. Since we already know that a is 3, so let us put ln of 3. And then, let us multiply this entire stuff into the derivative of u with respect to x. Now, since u is x squared, let's differentiate this one in terms of x. So, by using the power rule, we will obtain 2x. And then, let us simply separate those constants to those terms with independent variable. So here the constants are ln of 3 and 2. That's why nilagay natin siya sa first term. So we have 2 ln of 3 times the remaining terms with a variable x, which is the x, times 3 to the power of x squared. And then wala na siyang simplification. That's why we will consider this as our final answer. Another example, find the derivative of the function 4 to the power of sine 2x. So let us apply the same procedure. Recognize first who is a, who is u. Here, a is 4 and u is the exponent, which is sine 2x. And then let us use once again the formula, since it is in the form of base a. Now, a to the u is the given function, obviously, that is our 4 to the power of sine 2x. A is 4, that's why the next term is ln of 4, times derivative of u with respect to x. Here, u is sine 2x. Let us differentiate this with the help of chain rule. So, take note guys, remember, chain rule is the derivative of the outside function times the derivative of the inner function. Now, the outside function here is sine x. Now, the derivative of sine is cosine. That's why we will have cosine 2x. And then leave the inner function, which is 2x. The inner function is 2x, guys. So let us differentiate that and we will obtain 2. And then, ayusin lang natin siya. Separate the constants and the terms with variable x. The constants here are ln of 4 and 2. And then, tsaka mo i-follow yung mga terms with variable x, which are cosine 2x and 4 sine 2x. And this is our final answer. Now, let's have the third example. We have the derivative of y equals 2 to the power of 5t times 3 to the power of 4t squared. For this function, we have two terms separated by multiplication sign. The first term is 2 raised to 5t, and the second term is 3 raised to 4t squared. We can represent this as your f and then g. Take note, guys, the separator is multiplication. That's why we have to use the product rule. So f is 2 to the 5t, just like what I've said earlier. G is 3 raised to 4t squared. Now, let us differentiate. Copy the first term, then multiply to the derivative of the second term plus the second term times the derivative of the first term. So here, copy 2 raised to 5t, then simply differentiate this function. Since we already know how to differentiate exponential function with base a, so apply lang natin yun. Copy the term 3 raised to 4t squared. That's the a to the u. Then, a is 3. That's why the next term is ln of 3. Then, differentiate the exponent, which is 4t squared. Using the power rule, we have 8t. So, this entire stuff is equivalent to our first term. Next, let's move forward to the second term. Copy 3 raised to 4t squared. Then differentiate 2 to the power of 5t. Copy 2 raised to 5t. A is 2. That's why the next term is ln of 2. And then, differentiate the exponent. This is very simple. The derivative of 5t is 5. And then from here, let us separate those constant terms and those terms with an attachment of variable t. So, under the first term, the constants are ln of 3 and 8t. For the second term, the constants are ln of 2 and 5. Now, observe that both terms contains 2 to the 5t and 3 to the power of 4t squared. So these are the similar terms. We can proceed to factoring or factor this term out. On that case, we will obtain 2 to the power of 5t times 3 to the power of 4t squared. Then, jot down all the remaining terms. So we have ln of 3 times 8t plus 5 ln of 2. And this represents the final answer. Now let's move forward to the derivative of the exponential function base e. No? So this is much simpler compared to the base a. Now all you have to do to find the derivative is copy the given function, whatever the value of u, siya lang ang ilalagay mo. Okay. So that's have e to the u. Then multiply the result into the derivative of u with respect to x. Simply like that. Let's have an example. What's the derivative of the function e to the 7 of x raised to 7? First, as a beginner, recognize what is the value of u. So here, u is 7x raised to 7. Then, using the formula above, copy the given function, which is e to the u, or e to the 7 of x raised to 7, times derivative of the exponent, which is 7x raised to 7. Simply use the power rule. We will obtain 49x raised to 6. Under this result, the constant is 49. So it is better to move it into the first term. So The final case is 49x raised to 6 e raised to 7x raised to 7. Next example. Find the derivative of e to the 1 half x squared. Now, obviously, u is 1 over x squared. Then, copy e raised to 1 half x squared by the above formula. Then, multiply to the derivative of the exponent, which is 1 over x squared. Simply use the quotient rule. No? Quotient rule. Derivative of the numerator, which is 0, times, copy, the denominator, which is x squared, minus, copy the numerator and differentiate the denominator, which is 2x, all over denominator square, which is x squared raised to 2. By simplifying, we have negative 2x all over x raised to 4. Since we have x term under the numerator and x term under the denominator, we can cancel this one. Okay? So, it will yield into negative 2 over x cubed. And then, simplify, we will obtain negative 2 e raised to 1 half, e raised to 1 over x squared all over x cubed. Now, let's move to the derivative of y equals e raised to 2x plus ln of x. So, before we start the solution, allow me to recall some properties of exponential and laws of exponent. If we have a raised to m, then ina-add natin yung exponent na m into another variable which is n. This is equivalent to a raised to m times a raised to n. Okay. Another case, pag meron kang e raised to ln of x, whatever the value stuck inside the natural logarithm, that value is also your answer. Okay? So for example, e raised to ln of 2. So since 2 is the value inside the natural logarithm, the answer here is 2. If you have e raised to ln of square root of 5, so the answer here is square root of 5. Simply like that. So let me erase this one. Let's have this. E raised to 2x plus ln of x. Here, u is 2x plus ln of x. Then, using the above formula, we can transform this one into e raised to 2x times e raised to ln of x by this property. Okay. But we all know that e raised to ln of x is just equal to x. Let us apply that property into this term. So, it will yield into e raised to 2x times x. Now, this is the time that we can use the product rule. This is your first function, f. This is your second function, g. Okay. Now, let us copy the second function, then differentiate the first term, which is e raised to 2x. The derivative of e raised to 2x is itself times the derivative of the exponent, which is 2, plus e raised to 2x times the derivative of x. The derivative of x is 1. So, copy mo na lang e raised to 2x. Observe that for each term, e to the 2x is present. We can factor out e to the 2x. So we have e to the 2x times the remaining terms 2x plus 1. And this is your final answer. Now at this point, nasa third formula na tayo, which is derivative of natural logarithmic function. So how to differentiate the ln of x? Simply get the reciprocal, then multiply the derivative of that function with respect to x. For example, find the derivative of y equals ln of 3x squared minus 6x plus 8. So, kitang-kita naman guys, no? This is your letter U. No? Okay. Now, apply the above formula. Okay. So, we have 1 over 3x squared minus 6x plus 8 times the derivative of that polynomial. So, simply apply power rule, and then sum and difference. We will obtain 6x for this term, and derivative of this term is negative 6. We don't care about the derivative of 8 since this is only equal to 0. And then, multiply this fraction to this term. We will have 6x minus 6 all over 3x squared minus 6x plus 8. And it represents now the final answer. Next example, what's the derivative of ln of x all over x plus 1? So, itong term na to, ito ang u pa din natin guys. So, we have u equals x over x plus 1. Then, apply the above formula. So, we have 1 over x plus 1. Okay. Ito yung u natin ha. Don't forget. Okay. So, nasatisfy natin yung term na 1 over u. Okay. Next po is differentiate the u, which is x over x plus 1. Here, let us apply quotient rule. Ano ba ang derivative nito guys? Check natin. Okay. Denominator times derivative of numerator, which is 1, okay, minus numerator times the derivative of the denominator, which is also 1, all over denominator square. In that case, observe the numerator class. No? We have positive x on this location. We also have x here, but at this time, naka-negative. So, this will cancel, x minus x. And the remaining term is 1. So, in that case, we have 1 over quantity x plus 1 raised to 2. And then, under this term, guys, let us simplify this one. So, reciprocate lang natin. X plus 1 will transfer under the numerator while x will remain under the denominator. So, in that case, we have x plus 1 over x. And then, copy the second term. Okay. Now, observe that we have x plus 1 here. This is a single piece. Then, x plus 1 here. We have 2 pieces of x plus 1. And then, this will cancel. So, the remaining term here is only x plus 1, that binomial. And, yun. Makuha na natin yung final answer. We have 1 times 1 is 1 all over. Pagdikitin mo lang tong x and quantity x plus 1. So, the final answer is 1 over x times x plus 1. Now, you can practice yourselves, guys. So, here's the 5 examples of functions that we have to determine its derivatives. Okay. can either use the derivative of exponential functions base A and base E, or the derivative of natural logarithm. And that's all for today. Thank you so much. This will represent as your assignment, guys, to be submitted next meeting. Okay, write your answer, your full solution in a clean bond paper. No? It must be a short bond paper. Okay. You can also use the technology, MS Word, pwede naman po. Construct nyo yung solution po doon. Okay? Copy and answer po yan. And then, thank you and goodbye. See you next meeting po. God bless.